Ricardo Ferreira, presenting hidden secrets about instrumenting the JVMs for OpenTelemetry. So Ricardo works for Elastic, the company that does Elasticsearch and so on. And well, go for it, Ricardo.
All right, I appreciate it, Bruno. Thanks for the introduction. So welcome everybody to the session. I appreciate everybody that could join us here at the JNation conference. That's arguably one of the best Java conferences out there. And today we're going to be talking about how you can leverage some of the, well, first of all, we're going to be talking about instrumentation using OpenTelemetry. So that's the first. So for those of you that are thinking of starting a project that has to do with instrumentation, I think that's going to be like some useful knowledge that you're going to get from here. But more importantly, we're going to uncover some of the, at least in my perception, some of the kind of hidden knobs that most people are unaware that they exist, right? And in my experience, they have a huge impact in how you are actually not only instrumenting, but showing your application, your JVM applications to the world via some observability platforms, right? So I think the best way for us to start, I was thinking about how I would start this presentation, and then I thought, all right, OpenTelemetry is relatively a new technology, right? It's a new project, has been around like for 1.5 years, give or take, but it is not mainstream yet, right? So it is fundamentally created, it was fundamentally created to replace OpenTracing and OpenCensus, and therefore, most developers are not aware of that they even exist. So what I'm going to do right now is to give you kind of a crash course, right, into OpenTelemetry. And for this, I brought you a demo that I'm going to show here right now and show you the code, show a little bit about which I activated manually, what was done automatically, so we can all be on the same page when I actually start discussing the theme of this presentation, which is the hidden knobs. After all, I have to make sure that everybody is on the same page regarding how they see OpenTelemetry. So long story short, OpenTelemetry is this observability framework that is purposes and targeted to cloud native applications, right? It has support for different programming languages, although we are going to be focusing today here on Java and JVM applications, right? And when you instrument your applications using OpenTelemetry, you're going to have probably two approaches, right? And they're not necessarily mutually exclusively. You might have projects where you are using the both of them, or ultimately you're going to have to pick and choose one of those approaches. The first approach is if you consider this as your backends, right? The backends is how we call the observability platforms that you're going to use to watch your application, right? So the first approach is that you're going to use some libraries within your application. So in case of Java applications, you're going to put a bunch of jar files in your class path, and then you are basically going to embed this concept of an agent, right? Which can be created either automatically or programmatically. We're going to discuss this later. And then the agent is going to be responsible to write directly into the backend the telemetry data. And what we call telemetry data, it can be either metrics or traces, right? The project itself, it's supposed to support logs, right? But this is not done yet. This is something that's being discussed and developed in the community. So for the sake of what exists today, we're going to be focused on traces and metrics, right? So when you are actually going to use this approach, well, first of all, you're going to use this approach when the backend itself supports the native protocol for OpenTelemetry, right? So that's the first, right? If your backend does not support the OpenTelemetry support natively, you're going to have to create some translation layer in the architecture which is the case of using the collector, right? So in this case, you're going to have an application that is being instrumented using libraries, and then all the telemetry data is going to be sent to this, let's call collector. Well, his name is actually a collector, so you can call it. And the collector is going to be responsible to be this man in the middle, a broker per se, that's going to do this translation of protocols. So it's going to receive OpenTelemetry protocol and it's going to send the protocol that the backend observability platform supports. In our example today, I'm going to be using Elastic APM, right, which is an observability platform that does support the OpenTelemetry protocol natively. So we're not going to be using here a collector, right? But in the code that I brought you to here today, And this is the link of the code. I'm going to provide this link after the presentation on the Slack channel. So keep in mind that, keep your eyes on that as well. And our friends on the backstage are going to help also to share in the YouTube channel if possible. In the code that is on GitHub, there is 2 Docker Compose files. One that does use the collector, and another one that does not use the collector. So you will have examples of using the 2 approaches. So keep that in mind, right? So let's go for a quick demo so you can have a first feeling about how OpenTelemetry works, so we can start discussing OpenTelemetry hidden secrets, right? Which is the reason why we are here. So what you're actually looking here, let me filter for the last 5 minutes because I don't want to bore you down with too much noise. But what we have here is what we call, let me actually increase the font size because I'm pretty sure it's too small, right? Probably is going to be better now. What we have here is what we call Elastic Observability. It's an observability platform that is created by Elastic. And what we have here is a session called APM, which is the Center for Application Performance Monitoring, in which is shown here one microservice written in Java. Specifically, it has been written in Spring Boot. I'm going to show the code in a minute. And if we click on this microservice here, you're going to see that there's one transaction here called hello, right? So the /hello represents the transaction that we have here. If you click on this transaction, you're going to see some high-level metrics like about throughput, latency, error rate, and time spent with spend time. And more importantly, you're going to have this, what we call a timeline of the transaction. So each time, this is a simple hello world. Like if I call it, let me call it right here. You're going to see that basically what this microservice does is expose it on the port 8080/hello. It basically says hello world, right? Of course, this is hello world. And then, but each time this endpoint is executed, this whole transaction is executed. And as you can see here, it's very, the word here is observable, right? It's very descriptive, right? Because you can see that, all right, this is the entry point of the transaction. And then after this, this is the endpoint of the method on the Spring Boot application that I've created that was called controller. The class was controller, and then the method was hello. And then after that, within that context, I created 2 span child spans, right? One of them was created kind of automatically. I'm going to show him. And the other one was created manually. So let's discuss this now, right? So how do I create this build response here span somehow automatically? So let me show the code for a second. So this is the code of my controller. As I said, this is Spring Boot application, plain simple Spring Boot application. And this is the entry point of my hello method, right? So I've annotated here using the @request_mapping annotation /hello. And then every time it needs to produce a response, it called this method here called build response. So let's take a look on this method over here, right? So how do I create this child annotation here? Because I've used this annotation called @with_span. So every time, we're going to discuss this later, but every time you want to explicitly represent a method that is part of the transaction using Java, you can just decorate the method with that annotation. Very simple, right? Why is that annotation exist? Because sometimes you might want to actually create things manually. So this my span over here is an example of a span that was created manually. So if we look how I created this span, let's go back to the hello method, which is the entry point, right, of the endpoint. You're going to see that, right, given the tracer, I used the span builder to create a my span, right? And then I started the span over here that I've called span, right? And then I basically executed a portion of my code that ultimately you would do something interesting for the microservices, basically just checking if the response is valid, which is kind of a dummy, but for demonstration purposes works. And then I've ended the span, right? So why is it important every time you create a span, you end the span? Because this is what's going to actually dictate the duration of that span, right? So if we look at here, we're going to see that this span specifically took 165 microseconds. So that estimate was only possible because I've created a span and finished the span, right? The other one, the build response that was created using the annotation, I didn't have to use this because the whole duration is dictated by the execution of the method. So Somehow behind scenes, there is some interceptors, just like in a typical Spring Boot word, that basically do some callbacks and then monitor the execution of the method and then publish this to the trace. So that's how it's done, right? And more importantly, as you can see here, I create the span here from the tracer. And how do you retrieve a tracer and the Java word? Just call this, like, let's call singleton, right? Class called global OpenTelemetry, and then you can create as many tracers as you want it, right? The class itself is singleton, but the tracers itself are not. So every tracer, they have a state, and you can usually keep them in a very scope on your applications to be reused across the code, right? So all of this, okay, just to wrap up, all of this was only possible because, and this is all running on Docker, right? So in my Docker file that creates the image for this microservice, I basically, what I do is to grab the source code of the microservice, and then I put into the Docker image. I run a Maven build very quickly, and then here's the magic, right? I download here this OpenTelemetry agent, which is a Java agent. For those of you that know Java, there's the concept of an agent in the Java word. And then the agent is actually used to execute the jar file that represents the microservice. So that's how it is so simple for you to actually create a tracer from this global OpenTelemetry singleton object, right? If I didn't have used the agent as I've used it right now, this call over here wouldn't work. So we're going to discuss this because this itself is one of the hidden secrets, right? But just keep that in mind that in this example, for both using the collector or without the collector, I am using an agent, right? So that's what makes the magic possible, okay? Also, I am also creating some what we call metrics, right? So this is an example of a matrix. So just like I create a tracer, I can create a meter, right? And the meter, from the meter, you can create what we call stateful counters. And those counters, they're stateful because they're actually stored on the backend platform, in my case, Elastic APM. And the reason why they're stateful is that by the time you send some calls to increment or decrement the values of those counters, this increment and decrement happens on the backend, not on your application. So there's no actual state being held in your JVM heap, right? So this is how I create a counter, and I'm actually using right here. So every time the reload method executes, I'm increment and +1 the number of execution, which is the metric, right? So if we look into the observability platform, this is Kibana. So this is what is behind Elastic APM. So for those of you that are familiar with the Elastic Stack, it's plain old Kibana, right? And then if I refresh it here, and here's the metric, I'm going to filter to only show documents that contains that metric. You're going to see an example of a document that has been indexed on Elasticsearch that represent that metric. So the name of the metric is count the number of execution, and presumably where the count, here we go. So the current count is 357, right? So because the Hello World app microservice is being called every 5 seconds, if I remember, on a Docker Compose. Let's double check. The Docker Compose is here. Yeah, every 5 seconds, the Hello World endpoint is called, right? So point is, everything is running on the agents that makes possible for you to not only create traces, but metrics, right? So let's wrap it out over here and start discussing what actually matters, which is the hidden secret. What I have shown here, presumably, none of this is hidden. If you go to OpenTelemetry.io, you're going to see all the instructions for do everything that I've done here. So it is no secret, all right? So let me know later if you have any questions about what I'm showing here at this point, and I will gladly explain. So let's go back to the presentation after the quick demo, because woo, now we are all caught up. No, we can start discussing the actual hidden secret. So first of all, right, my name is Ricardo Ferreira, and I'm a developer advocate with Elastic, right? In Elastic, I'm part of the community team, and my job is basically, although not only speak about Elastic, of course, duh, but I'd also, I'm very, like, engage it with some other technologies that I like it to talk about, like observability, distributed systems, streaming systems, and databases in general, right? So this is what I call, this is my jam, right? And in here, you can see my emails. If you want to get in touch later, my email from Elastic, my email, my personal email, right? And if you happen to use Twitter, @Ferreira is how you can get in touch, right? So with that said, let's start discussing the hidden secrets. And the first one is actually a bummer, right? Specifically for us Java developers, because if you understood the concept of the agent, right, you're going to have this perception that, yeah, it's so simple, right? I'm just download the agent, run my application with the agent, and everything else, the injection of the tracers and the meters is going to happen automatically. So I just go ahead and use them, right? Yeah, exactly. So I would say that the usage of the agent represent 80% of all the Java developers going to use, right? Because it's handy, it's simple, right? And it provides you a very seamless experience in how do you work with OpenTelemetry. And the agent itself is open source. So just grab it, use it, right? You don't have to do anything else. However, and this is what I've discovered after talking with some developers in the community, you might have heard that there is this trend of Java developers building native applications, right? You name it. Either if you are using GraalVM, Quarkus, or Spring Native, those technologies, fundamentally, what they do is to kind of create a native version of the code. So ultimately, it's going to execute faster. Yay. This is what ultimately everybody wants. However, there's one catch, right? In order for those technologies to actually create the native version, they have to know upfront all the code, right? And if you recall, the concept of an agent in Java is basically to do dynamic instrumentation. So this is code that wouldn't exist by the time you actually compile your application, right? So I would say that there is a 20% of cases that you would have to leverage not only agent, but on the API, SDK, and some of the extensions from the OpenTelemetry project, right? So because of this, if this is your case, you are planning to use Quarkus from Red Hat, for example, which is amazing, but you want to instrument using OpenTelemetry, you might need to give up your agent, the simplicity of the agent, and write your code way out to build and instantiate everything that the agent does, right? Which is not so complicated. Here's an example of, you basically have to create a tracer provider or a meter provider if you want to work with metrics. And then you have to come up with something called the OpenTelemetry. Everything else in between this and this is going to be customizations that you would do, such as, oh, I'm not going to use the sample span processor. I'm going to discuss this later, but I'm going to use the batch span processor because it provides high performance, right? So the coding of this customization can take time. It is somehow boring. And if you would like to skip this whole board, you have the option to write them manually, right? There's nothing wrong with this if you writing code. But first hidden secret is that there is this module called OpenTelemetry SDK extension. So as the name implies, it's part of the SDK extensions for OpenTelemetry that provide this auto configuration. So how this works, all the customization can be done using environment variables or Java properties, right, that you pass to the JVM. And then you simply call this one line here called OpenTelemetry SDK auto configuration .initialize. So everything else is going to kind of transverse all the environment variables or Java properties that you have passed it to the JVM, and it's going to build up the OpenTelemetry object, which is going to be a global single object that from there, you can create tracers and meters, right? So it's quite simple. So there are strategies that you can use to overcome the limitation of, all right, I'm going to run Java native applications, but I don't necessarily want to write a bunch of code in order to do instrumentation with OpenTelemetry, right? So keep that in mind. We've mentioned this before. So if you want to actually not, because this is simple when you create a span and then you can simply use the span, decorate the span, and end the span. It's not a very complicated programming, but it can be kind of a boring if you have to do for every single piece of code that you want to highlight in your transaction in the observability platform. So one of the ways is to use this @span with span annotation. So I've just shown you how this works. So at this point, just keep in mind that you have to actually explicitly introduce this dependency in your project. Either if you're using Gradle or Maven, this is not part of the core or API project from OpenTelemetry. This is an extension, right? So if you don't include it, it wouldn't work. You would end up with a no class that found error. So keep that in mind, right? Also, this is kind of a more like a best practice. There will be situations where, let me put it this way, the our instrumentation is very good, right? So all the libraries and framework that are kind of compatible with OpenTelemetry will be automatically discovered by the agent, or if you manually instrument your JVM. But sometimes there will be too much noise going on, right? Because everything was automatically instrumented. And if you happen to have an application that has hundreds of dependencies, and those dependencies, you might be like, okay, some of them might be kind of breaking the application because I've enabled the instrumentation. You have this flag over here that you can temporarily disable only the auto instrumentation, right? So what that means that all the instrumentation that you have written manually, or if you use the at with a span annotation, it would still work, right? So it's only going to disable what has been instrumented automatically. So this is kind of handy for troubleshooting purposes, right? And same goes if you want to do the inverse, right? I want to kind of eliminate all the everything that I've done manually, and I'm going to make available only what is kind of been automatic instrument. So in here, you're going to disable everything that has been generate all the spans that has been generated from the with at span annotation, right? So this is a way for you to troubleshoot things, because this happens, right? You might, specifically in your first OpenTelemetry implementation, you might see cases where, all right, after I've introduced an OpenTelemetry something or some frameworks are, because compatibility, versioning, or something else, stop from working. So you might have to have ways to troubleshoot this, right? Observability is all about making things observable, right? So how do you do this, pragmatically speaking? You have to start off by giving proper names to things, right? So in this example over here, right, when I show you the, let me go back to my observability platform and go to my APM session. So as you can see here, I have this very handy name called Hello App, right? So when this name was actually generated, because I've actually exported an environment variable that you can use called OpenTelemetry.resource.attributes. So as name implies, you can attach attributes, and there are some conventions that the OpenTelemetry project created. For example, service.name. This is whatever you set here is going to be how your microservice is going to be shown in the backend platform, no matter what the backend platform is, right? So keep that in mind. And you can use environment variables or Java properties. It doesn't matter, right? Same goes, right? Same goes. If you are manually creating spans, as like we are doing over here, the span itself can have extra information. Making sure you are adding extra information in the span is useful, because you want to make sure that whoever is reading the code, right? Because think about this, right? Not all the time, you are actually going to be the same person that wrote the code is going to be the person that actually is observing and monitoring the application. So they have no idea about what the application does and how they do, right? So as a developer, you want to make sure that you provide as much information as possible. And you can do this by using what we call the labels and decoration process. So you got to be thoughtful on that, right? So as I mentioned before, pretty much when you were talking about tracing is mapping an end-to-end execution of a given transaction, right? And for some technologies, it's quite simple to implement, right? And it's almost kind of a automatic. If you're dealing with, let's say, HTTP protocols or gRPC protocols or something that is synchronous by nature, right? So OpenTelemetry has great support for this, but there will be some situations for frameworks or technologies such as messaging brokers or things like Kafka or Pulsar. You won't necessarily have this kind of a out-of-the-box end-to-end instrumentation, because now your producers and consumers are running on separate threads or processes, right? Or even different layers of your architecture. So you got to have actually find a way to tie those services together to make sure that you're going to still see the transaction end-to-end. And the OpenTelemetry project provides this, what we call a TEXT-MAP-PROPAGATORS, right? So let's see in an example like we see here, that within this method over here, I publish a message to Pulsar, and then there will be another consumer, which happens to be written in Go, right? Forget about it's just an example, but this Go microservice is going to pull the message out from Pulsar and continue the processing. What is important here is that the producer is written in Java and the consumer is written in Go. So they're obviously running on different processes. So in the Java part, you can come up with what we call a setter, right? This is a abstract class that you basically have to provide an implementation of this callback method called set, right? So the set method basically is going to teach, right, OpenTelemetry about how to include the context that has been created in one layer into what we call a carrier, right? A carrier, as the name implies, is going to be this component that's going to carry the context from one place to another. And in case of Apache Pulsar, is going to be the actual message, right? So your set callback is going to somehow ensure that some piece of information is introduced and added to the message. Once you provide the implementation of the setter, you can simply call global OpenTelemetry get propagators, get TEXT-MAP-PROPAGATORS. This is the feature that we're talking about. And then you can simply call the method inject. There are three parameters that are expected here. The context itself, right, which is all the baggage that was created in one layer. The carrier, which in this case is the message, and the setter, right, which is how you're teaching about how to introduce the context into the message, right? So very simple. TLDR, you just need to come up with this abstract implementation of the setter, right? In the other side, even if you had a Java implementation, you would have to come up with a getter, not a setter, but a getter implementation. Or in case of Go, you can simply do this, which is creating an implementation of the kind of a similar, like you create an implementation of a carrier, and then you have to provide callback for get, set, and keys, right? Ultimately, what we are doing here is extracting the context from the existing message. So this is how it works, right? This is very useful. So this, I have used this before, and it's quite handy when you need to use it. So as you can see, for all of us that have been using JDBC for long years right now, or JPA, you know that by default, all the parameters that are sent to SQL statements, they are actually encapsulated and keep it hidden, right, for security purposes. And this is a best practice. This is good, right? But there are situations where you want to see the parameters, and OpenTelemetry does this as well, because it is a best practice. By default, everything is encapsulated. But if you want to uncover all the values for SQL statements, just set this property here, right, to false. Oh, by the way, don't need to keep in notes about all these properties that I'm showing here. I'm going to make this presentation available. It is already. I'm just going to provide the link later. So just make sure to understand, and then you have copies of this presentation later. So you will be able to remember all these little parameters here, right? By default, this parameter is true. If you want to do this, just set it to false, right? Another one, and this is kind of a, I don't know if this is a good thing or a bad thing, right? We can discuss this later on the Slack channel, but by default, right, OpenTelemetry does not create a span every time your code create a JDBC connection, right? The reason for this, I think this is a good thing, but you tell me later. If you think about it, the probability of frameworks such as JPA or Hibernate or IBEX or whatever frameworks that you are dealing with persistency to create a JDBC connection is going to be very frequent, and it's going to be very noisy if you have to create a span. So that diagram that I've shown before in the observable front, you have lots of child lags, and it will be a little chatty to see. So by default, this is disabled. But if you want to enable, right, just set this property here. Kind of, this is another hidden property. You set to true, and then voila. So if you are worried about none of the JDBC connections are being shown in your observability platform, this is the reason. This is kind of a hidden trick that you can uncover. All right. The same goes if you are dealing with frameworks that are too much noisy or chatty, right? So what you can do, for example, let's say, this is not true, but let's say, this is just an example, right? The Natty framework is extremely noisy because it creates lots of spans given the out instrumentation. But what you can do is to specify some of the Java classes or packages that you want to exclude from the actual instrumentation. So you can minimize a little bit of the noise by doing this. You can specify this in a package level or in a class level, which is pretty handy, right? Another thing, let's talk about performance, right? Everything in the tracing world for OpenTelemetry has to do with spans, right? So if you got the idea at this point, everything when you are instrumenting a end-to-end transaction, all this transaction is going to be broken down into an entity called a span, right? So in order for a span to end up in the observability platform or someplace else, it has to be processed. So there's this concept of span processor, right? There are, by default, there's a bunch of span processors available out there. Some of them are not part of the OpenTelemetry project, but what is default from the OpenTelemetry project is the simple span processor and the batch span processor. I would highly recommend you to prefer using the batch span processor, because the simple span processor, for every span created, it creates a network call to transmit that span to the backend, right? Not very efficient, right? What you can do is use the batch span processor, or DSP as we call it. So the batch span processor gives you ways to configure, and this setting is what I consider a little hidden because it's not so trivial, right? Most of the time you are simply using the BSP, but you are not aware that you can configure the size of the buffer, the delay that you were going to wait until you flush them to the network connection. So there's a bunch of knobs that you can turn to improve efficiency, right? And you can use this either if you're using a collector or if you are not using the collector, right? Which is in the case of a demo that I've shown before, right? The other thing also related to performance is the concept of sampling, right? So let me take some time to explain this sampling concept, right? Because this is very important, right? When you were instrumenting an application, right? From time to time, OpenTelemetry capture samples of the traces, right? Which is, if you don't configure your sample strategy correctly, you might end up with a one-on-one relationship about traces and samples, right? You don't want this. This is not very efficient because that will create too much chat in the network, in the outbound channels of your network connection that's going to be sent the telemetry data, right? Unless you want it, right? The only situation where I have seen this working is when you are actually testing the limits of your network exhaustion, right? If you want to check that, right? Otherwise, what you want to do is to create configure samples of your traces. So, because here's the thing, in order for you to come up with the idea that the average latency of a given microservice is 300 milliseconds for any interval of time, you don't necessarily to calculate the average of every single call that you have been executed. You can calculate this using samples, right? Unless you want to really make sure that you are not missing a single trace or execution from your application, right? And then you can create things like, okay, always on. So basically, this is create the one-on-one relationship that I've mentioned before, right? Let me just set up something here. Or you can simply create a parent-based or a parent-based trace ratio where you can turn the ratio of the samples that is going to be created, right? So this is something, in my experience, this is something that you often discover the worst way, right? It is not very uncommon for people to start using OpenTelemetry and find out situations like, yeah, but after I started introducing OpenTelemetry in my application, the application start to get slow, or the backend platform is not keeping up with the amount of data being generated. So this has to do with the sampling strategy. So be aware that there are ways and knobs for you to change this, right? And they are specified right here, okay? Same goes, right? Not everything, I'm a huge fan of the OpenTelemetry project and the implementation. So you probably, if you follow me on Twitter, you're gonna see that recently for the last 6 months that I've been talking a lot about OpenTelemetry. But at the same time, I am aware that OpenTelemetry is not like a 100% stable and 100% ready, and arguably it's not even 1.0, right? Although some of the releases says that 1.0, the general project's not 1.0 yet, right? So there are moving parts being discussed and refactored as we talk over here. Because of this, right, you might end up with situations where you want to debug your application, right? Because perhaps the code have changed. I have seen the situation a lot as a Java developer. Like, for example, I've wrote a code, like last week, I follow an example on GitHub about how to instrument using the current state of the API. And then 1 week later, when I tried to execute the application, my logs was saying, all right, no class that found error, or method not found error. So what's happening in the application? So because of this, you might want to use flags like enable debugging, right? Because if you look the logs generated by default, the info logs from OpenTelemetry, they don't tell you much. But if you enable this, boy, you gotta hold yourself into something, because you're gonna see a bunch of code being shown in your logs, and it's extremely verbose, extremely useful for troubleshooting purposes, not very useful in production, right? So remember to disable that when you go to production. But this can be quite helpful if you are unsure about what's actually going on behind the scenes, right? Specifically because pretty much in OpenTelemetry for Java is about dynamically instrumentation, right? So there's a bunch of things that kind of happens magically behind the scenes. Interceptors. For those of you that remember aspect-oriented programming, there's a bunch of aspect-oriented programming going on behind the scenes in the JVM. There's a bunch of waving and injections of code dynamically happen. So all of this can make the understanding about the actual flow of the code a bit blurry. So this is going to uncover certain secrets for you, right? And, right, this is another trick that it's pretty handy sometimes. Maybe you want to simply disable the agent, right? And you don't necessarily have to kind of manually remove the jar file of the agent of your entry point, because maybe you're using Docker or Kubernetes and you don't want to change your Docker image, right? The entry point that you set on the Docker image is already is using the jar file, and you don't want to change that because that image is supposed to be immutable, right? Supposed to. It's not necessarily conceptually it can be mutable, but it's supposed to be immutable if you follow the best practice, right? But sometimes what you can do, you can disable the agent using this flag over here, right? So this flag allows you to completely disable either the automatic and manual instrumentation from your application. So you can see things like, okay, let me see how my application behaves or performs without OpenTelemetry, right? And there are a thing called observable metrics, and there's no pun intended here because of the word observable, right? Because we're talking about observability, right? This is a resource, a feature that it is available, right, with OpenTelemetry. And this is quite handy because if you remember, I'm going to show the code one more time, but if you remember the example of the metric that we've created right before, you would see that, all right, it was a counter, right, that I've created and stored it into a private static field of a Java class, right? And then in different parts of the code, I can simply call that counter an increment. So, but that call itself needs to be explicitly done. I have to write down the call itself myself, right? Just like I did before. With observable metrics, you can create metrics that are, they execute by themselves in a frequency that you can specify here, either in the configuration or in the code, right? So this is an example of how the application can proactively calculate its own heap memory, right? So in here, you provide simply an updater, an implementation of what they call an updater. Everything else is just a metric, plain old metric. But if you associate this meter with an updater, this updater will be periodically executed and is going to come up with some logic that you're going to provide, right? In here, I'm just calculating the total amount of memory usage for the JVM, right? I'm not sure if this code actually makes sense in container technologies, but you got the gist here, right? Let me show you actually how this code works, how this code is actually behaving in my code. We have some time, so I think we are good.
Yeah, we are good.
Yeah, we have about, just to see if my counting is correct, we have about 20 minutes per se, right?
We have 7 minutes.
Oh, my counting is terrible then. But still, we have some room for finish this talk here and then wrap up the presentation. So 7 minutes is okay. So in the code that I was shown before, right? So this is a Docker Compose that I was using, right? So this is the reload application, right? And then as you can see here, I have exported that my traces and metrics are going to use this protocol called OTLP, which stands for OpenTelemetry protocol, right? Oh, by the way, there are different protocols that you can use to transmit the OpenTelemetry data, right? OTLP is the default, arguably what pretty much everybody's going to use, but you don't have to settle down for this, right? There, you can use Zipkin protocols or Jaeger or even Kafka, right, to transmit the data for you. So you can tweak this using these properties over here. And then you have to set here the endpoint, which is where the telemetry data is going to be sent, right? And then this is currently pointing to my Elastic APM server, but let's say you don't want to use Elastic APM, you want to switch to Jaeger, right? And then you can simply point here to your Jaeger endpoint and everything else would work, right? This is the beauty actually of the OpenTelemetry, because you can code your whole logic of instrumentation and tracing and metrics, and everything else would work like flawlessly just because you're changing the backend, right? But I'm derailing a little bit. What I would like to say here is that there's this property here that says that every 5 seconds, the matrix that has been accumulated on your JVM heap is going to be flushed into the backend, right? So I've set here for 5 seconds, and in the code itself, right? Where is the metric? So here we go. So I created my meter here. I call it meter, right, for simplicity. And then I created 2 metrics here, the number of executions, or this is what we call a static metric, right? Because this one, I have to manually code how to mutate the value of it, either to increment or decrement. But this one over here, what I call the heap memory, is what we call a long value observer, right? It always starts with a data type because you can have an observer for long values, for float, doubles, int, right? So there are different data types that you can use. Maybe in my case over here, I've used it long because it represents well what the data structure that I want to create here, which is the amount of bytes, right, being used by the application. So as you can see here, I create a set updater. So this is my callback implementation of how to set the value. And this callback here is going to be in the background. There is a bunch of IO background threads that from time to time, given the time that you specify via parameters, execute this logic over here, which is pretty handy, right? So now you have a metric that simply is executing and flushing the data for you automatically, right? So if we take a look on this heap memory over here, let me just remember the name of that I gave. I call custom.metric.heap.memory. All right, so let's take a look on the last KPM, this metric. Discover. Okay, this is what I want to see. It's filtering for the last 5 minutes, and then we should have, oh, here we go, custom.metric.heap.memory. So let me filter only documents that has to do with this value, and let me pick up an example of a document here, right? So this is the metric. Where's the name of the metric? It's somewhere over here. I'm not wearing my glasses right now, so it's kind of hard to see. Oh, here we go. So let me highlight it for you. So this is the name of the metric, right? Here we go. And this is the current value of it, right? So which is set in bytes. So all of this, as you can see here, has been continuously calculated for you automatically, right? So observable metrics are handy ways for you to build up metrics, and you don't want to spend too much time. When it's possible, of course. There are situations where you need to hook up invocation calls to update the metrics throughout your code. But in this case, it makes sense to be something observable. And then the last hidden secret I would like to discuss with you today is something that it is quite useful, in my opinion, right? Because here's the context, right? Let me set you the context for when to use this feature over here, right? Let's say you want to start your OpenTelemetry implementation, but you still don't have a proper backend implementation. You're still deciding if you want to use Elastic APM, for example, or Jaeger or Zipkin or whatever observable platform your company wants to use, right? You don't necessarily have to wait, right, until you have an observability platform to start actually seeing what OpenTelemetry produces specifically in terms of traces, for example. One common approach that I started to use, and a lot of people kind of use, is using what we call a console appender, right? So as the name implies, everything that is a span processor that every span that's created, you can flush to a console, and then you can kind of associate to a log file, and then you can tail minus after log file, and you can see it from there. Works, but not necessarily very handy, right? There is this extension called JFR events. As you can see here, it's part of the SDK extension. So by default, keep that in mind, it's not part of the OpenTelemetry project. But if you associate with your application, right, you can start a flight. You have to use a JVM that supports flight recording, right? Hotspot or whatever other JVM supports flight recording. So you can start a flight recording of your JVM while it's being executed. And then all the traces that will be generated here will be kind of compatible with JMC. So you can simply, after you finish the recording, you can open up JMC, open the JFR file, and all the traces will be there. So you can visually not only see the traces, but their dependencies, like in a more hierarchical diagram. It's very handy to kind of see how the application is behaving, and more importantly, to observe the performance of the application and how much overhead the traces are introducing into your application, right? So keep that in mind. The JFR events span processor is pretty cool, and it works perfectly. With that said, thank you very much for all of you that spent this time today in the session about OpenTelemetry. I really appreciate your time. And for the organizers, for the JNation conference, thank you one more time for bringing me in. And I'm looking forward to further discussions with you about this theme in Slack, or if you want to hear right now. So thank you.
Thanks very much, Ricardo. Unfortunately, we have no time at all for for any questions or anything. I had one for you. So if there was an easy way to integrate old OpenTracing code with the new OpenTelemetry one, but well, I think we have to chat offline.
Yes, no, I will respond this question offline in the Slack, but there's kind of a way, right? Just to give a TLDR.
Thanks very much. I really enjoyed it.
I appreciate it, Bruno. Enjoy your day. Thank you.
Bye.
Bye.